Okay, so we're going to quickly talk about enthalpy and why we use it. So this is a really important concept for chemists because we can actually work out how quickly something reacts using its enthalpy. So basically with enthalpy, it's the heat changes that happen. And that's over the course of a reaction. And more specifically, it's when 1 mole of a type of compound reacts. And that's what we're looking for, is the difference between 1 mole of one alkane versus 1 mole of another alkane, for instance. Now, the easy way for us to actually determine heat changes is to look at how the temperature changes over the course of the reaction, because that's something that's really easy that we can measure. Now, to make a little bit easier for you in terms of the value of enthalpy, we're going to use 2 terms, and this is the system and the surroundings. If you understand the system and surroundings, you'll be able to understand what that value means. So we'll go through a couple of examples just to show you. So here's the first one, and this one you've probably done at home. So you've got an ice cube on your hand. Sorry for the very primitive drawing. And if we think about the system and the surroundings, the system is actually the reaction. So what I've got here is water that's in a solid form that melts to water that's in a liquid form. So this is the system. Now it's quite obvious that the ice cube here, that's the system. Now the surroundings, surprise, surprise, is everything else that's happening around it. So your hand is the surroundings, the air around it is also the surroundings, etc., etc. And what you know, or the temperature change that you feel, is in your hand. So this is your change in temperature. Now we know it gets colder. So basically what's happening is the energy that is inside your hand or inside the surroundings is going into the system. So we're getting this heat entering the system. Now what we can show that as is a positive change in enthalpy. So enthalpy is going into the system. And a positive one, you probably remember from GCSE, is called an endothermic process. So that's one way of showing system and surroundings, but we'll look at the opposite, and this is probably something that we'll use much more commonly. So let's say we've got an acid and a base reacting together. We form salt and water. Very usual thing that we can see. It's in an aqueous solution, so this solution here is aqueous, and in the solution is what we're actually measuring our temperature change using our thermometer. Now I'm just going to pretend, obviously we can't see the individual molecules, but let's pretend that they're there just so that it's easier for you to see. Now what happens is the temperature will increase. Now what's happening here is this enthalpy is actually going into the aqueous solution here. So all of this extra heat is being pushed into the aqueous solution. The aqueous solution is increasing in temperature, which is what we can see on the thermometer. So you'll notice that the energy is escaping the system. So we end up with a negative change in enthalpy. And this is called an exothermic process.